Later on today, I'm actually going to be giving you some questions from the old Physics 12 provincial exam. I've actually done far more than Science 9 with you guys right now, just to see if we could. So you ready? Kiana, you awake? Here we go. Basically, a lot of the questions on the test are going to be like D, where I'm going to say, find everything that you can, and I'll put V equals or R equals or I equals, so fill in every blank. What's our strategy going to be? First thing you always, and you may want to write this down if you want to, because now we're going to start to talk about strategy. You want to find the battery. In this circuit, where is the battery? And it may be obvious, but whereabouts? On the left. As soon as you find it, label which way is downhill. Now, we said this. We said, don't write this down, electrons go from negative to positive, but hopefully I've convinced you it's much more convenient to pretend that current goes from positive to negative. So we've decided current goes that way. Current goes, that's downhill. That's downhill, that's downhill. I'll follow this around, follow it around, follow it around, follow it around, follow it around. You know what? Down here, current is flowing to the left, there. Now, when you get really good, Lyndon, you might not bother drawing those arrows, but till we get good, I do. So find battery and show downhill. That's the first thing. We're on example D, which is, I don't know, here somewhere. Where we left off, you were here. Got it? The photocopy sometimes, you know, found the notes yet? Like I told everybody to find? You had the notes? So you look over at your neighbor. You can kind of see. Yeah, there, that looks good. Okay? Second thing. If I can find the total current, this question will fall apart. So what I do is I look for any sections of wire where all the skiers, all the current, must be going through. And if I can find that, that's a good thing. So look at this circuit. Did they tell me the total current anywhere? And I always start out here. Did they tell me the total current right here? No. Did they tell me the current right here? Amelia's nodding. And is that the total current? Was there anywhere else for skiers to junction off before they got there? No. Then I'm telling you this question's going to fall apart. What's the total current in this circuit? 5 amps. How many amps are there in this circuit? 5 amps. So now let's walk through currents. Do I know how many amps went this way? No. Do I know how many amps went this way? No. Do I know how many amps went through here? I do. How many amps must have gone through this bottom one? 5, because the skiers split up right there, but they joined up right there. I can fill that in. 5 amps. Then the last thing I do I write down, look for 2. I look for any resistor where I know 2 things, because if I know 2 things, I know 4 things. So, do I know 2 things on this resistor? Right now, I only know 1 thing. Current. Do I know 2 things on this resistor? Then I know 3. What's the current? So they told me V voltage, they told me ohms. What's the equation that has current and voltage and resistance in it? And please give me the one that has the current by itself. It is I equals V over R. Can you say that without a question, with a statement of authority in your voice, like you know you're right? Okay, now, I got to pause. Do you all see how she found that? She went to the yellow formula sheet, the one that I told you should be looking at. She said, look, they gave me these 2, V and R, and I want I. So she said, hey, I'll jot this in the margin here. In this resistor, how many volts do we lose? 15. What's the resistance? 5 ohms. You know what? I can do this one in my head, Mateo, without a calculator. 15 divided by 5. How many amps must be right here? Got to be 3 amps. Instantly, I know how many amps must be over here. Nope. Amelia, what? 2. Why? How many are coming in? 5. How many went down this way? How many must have gone the other way? This is the current law. Skiers can split up and meet up, but they can't vanish. 2 amps. Oh, and by the way, I wrote V equals 5 amps down here. Sorry, I should have put the 5 amps next to the I, shouldn't I have? Is that what some of you are looking at? Sorry. Do I know 2 things in that bottom resistor? Do I know 2 things here? Then I know 3. What's the equation that has the V by itself? How many volts do I lose? You know what? I think I can do that one in my head too, because it's going to be 5 times 4 is? Okay. And then the last thing that I do, by the way, are there any other resistors where I know 2 things? No? I ski circles. By circles, what I really mean, Kiana, is I always end up back where I started from. They're going to be rectangles, I guess, because I'm not drawing circular circuits. I'm drawing jagged lines. But so you ready? Hudson, you awake? You awake? Here we go. Hudson, how many volts right here? Just read it. So this battery is giving 70 volts. That means our skiers, our charges, are starting with 70 volts. How much do they lose down this hill? I don't know. How many volts do they lose down this hill? How many volts do they lose down this hill?
20.
Which? 20? Right here. I'll even put the... Okay. So you ready? Lena, here's our reasoning. How many volts right here, Mateo?
70.
I don't know what I lost here, but I lost 15, I lost 20, and I got back to the ground. How can I figure out how high this hill must have been? Now you might need a calculator. I start 70 high. I don't know what I lost there, but then I lost 15 volts more and 20 volts more, and I'm walking in a closed path. I'm ending up back where I started from, a circle. Got to be 35. This resistor, we must have lost 35 volts. We had to have. Otherwise, we would have voltage unaccounted for, and this circuit would be on fire or bad or something, short circuit, something's wrong. Hey, do I now know 2 things in that resistor? By the way, some of you are looking a little puzzled, right? So here's what they said. They said, well, I'm starting with 70 volts, and the second hill was 15, and the third hill resistor was 20. You know what? That first resistor had to have been 35. Otherwise, there's no way that I can go like that and end up back where I started from at the bottom of the hill. Is that okay? Hey, I know the current. I know the voltage. What's the resistance? What's the equation that has the R by itself? Now, I'm writing these in our notes. Are you okay if I don't do that anymore because I gave them to you on your yellow sheet? Okay, but I'm just showing you what they are. Oh, V over I, 35 divided by 5. What's the resistance? 7? And what are the units for resistance? The little funky mouse hole symbol. Have we filled in everything yet? Nope. Let's go to the right-hand side. Do I know 2 things on this? Then let's go ski circles. And the circle I'm going to ski this time is that one. So you ready? How high? How high? 70 volts. Okay, that's our chairlift. What do we lose going down this hill? 35. Leaving how much? Start out with 70. I lose 35. We have 35 left. You can use your calculator. Do I know how high this hill is? Nope. How high is this hill? 20 volts. And we got to the bottom. Yeah, we got that part. We're there now. Okay? So, you ready, Aiden? How high? Minus. Leaving. So keep skiing, keep skiing. Do I know how high this hill is? No. How high is this hill? 20. And I got to the bottom. What must this be for that to work? It's got to be 15. Has to be. Now, this bugs some kids because if you add up all the voltages, it adds to more than 70. You don't add up voltages. Voltages, if you go in a closed circular path, then they'll always add up to the battery. Do I now know two things on this resistor, Kiana? Then you know what? I know three. R equals V over I, which is what? 7.5. Amps, Mr. Dueck? Ohms. So these are kind of, Lena, sort of like jigsaw puzzles where you kind of hopscotch step by step. I like these as little brain teasers, and if you don't panic, it's all there. Oh, by the way, as a bonus or a follow-up or a part B, what does power equal on your formula sheet?
No, it doesn't.
On your formula sheet right in front of you,
Power equals.
is it not V times I? Oh, so instead of asking you to find, I could ask you if these are all light bulbs, how many watts are they? How many watts is this top light bulb? V times I. Got a calculator, go ahead. How many watts is this light bulb here? 175? How many watts is this middle light bulb here? Right, V times I. You shouldn't be guessing. You got a calculator. That's why I gave it to you. Times. 15 times 5. 70, 75? Oh, 40, 15 times 3. 45? Okay. How many watts is this light bulb? How many watts is this light bulb? By the way, this light bulb here? 30 watts? How about the bottom light bulb? How many watts? 100 watts. Times. Right? Times. So a good question, which would be really scary at first, would be instead of me saying find everything, I could have given you the circuit and said which bulb is brightest. Which bulb is brightest? The top one. The top one. Has to be. That's a shame. By the way, this was a glitch when I pasted. This line right here should really be right there for the battery. But I couldn't get it to move. I tried. Oh, I know what I can do. Haha. I'm going to go pen. I'm going to go draw. Color. White. There. That's what it's supposed to look like, but there was something wonky in the drawing, and after trying for 10 minutes, I gave up. Okay? All right. Let's find everything. First thing, what did I say? What's the first thing that I look for? There it is. How many volts is this battery? 32. Which way is downhill? That's which way the current goes. Electrons go in the opposite direction. And like I said, Benjamin Franklin named negative and positive backwards because it would have been much nicer if he had named electrons as positive because then the numbers would be... Anyways. Second thing we look for is, what did I say what I always look for next? Total current. So starting on the chairlift right here, did they tell me the total current here at all?
Yes. No.
Which one? Yes or no? No. Keep skiing, keep skiing, keep skiing. Now we split up. Did they tell me the total current here at all?
No.
Okay. That didn't help. What was the third thing I said I do?
Look for two.
Is there anywhere where I know two things? Oh,
Yes.
right here. Then I can also find the third. What's the current have to be?
I will choose B.
That's got power. Don't use the one with power in it. I didn't give you the power on this one.
I will choose right.
Can you crunch the numbers, please? Now, I will let you, in your homework, if you want, just put the answers there, and I will assume you typed them in. Now, that means, because I'm giving you the answers that you can cheat to your heart's content, is your test next week? You'll flunk the test. But what I won't make you do, Rihanna, I won't make you somewhere write I equals V over R equals 8 over... You can. I have no problem with that. But if you just go, I'm totally good with that. It is 4 amps, yes?
No.
8 divided by 2?
Yeah.
Okay. So you can, Kiana, write that if you want, because I know some kids really like to show work everywhere, and I'm great with that, but I also know some kids are like, Mr. Dueck, if I'm just typing it, why can't I just type it? And I'm good with that too. All right. Why is that so nice? Well, no, but why is that what we just found so nice? I know it's not a decimal, but why is it so nice? And I'll give you a hint. What was step 2? What was step 2? What did we just find? There you go. And I've told you, as soon as you know the total current, I'm telling you, the question's going to fall apart. You'll have to hopscotch a lot, but it's going to fall apart. So let's go skiing. How many amps right here? Still 4 amps. How many amps right here? Now it splits up. Do I know how they split up? No. I can't assume that. Could be 1 and 3. Could be 0.8 and 3.2. I don't know. So we've got total current, though. We've said anywhere that there's 2, we've done that. What was step 4? Okay, so the first circle I'm going to draw on mine. You guys don't need to draw on yours. The first circle I'm going to do, I think, is that one. So you ready? Let's ski. This is kind of fun. It's like holidays. Tristan, how high is the chairlift? 32 volts. So we need to get rid of 32 volts. Ready? Look up, look up, look up. Ski with me. How many volts do we lose here? Leaving? 24. Do I know how high this hill is? No. But did I end up back at the bottom? Then how high must this hill have been? Has to be. Has to be. Yeah. Has to be. Ding, 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 ding. Do I now know 2 things? Then I know 3 things. What's the current have to be in that particular resistor? And again, it's going to be $2.4? I think it's going to be 24 divided by 10. Right? Is it not? By the way, I can't be 24 amps because my total current is 4 amps. So we can't magically get skiers. 2.4 amps? 2.4 amps. How many amps did we start with here? 4? How many amps went this way? How many amps must have gone this way? Do the math. How can I figure that out? Yeah, but more specific. What? Take away what? No, 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 no. 24 is voltage. How many amps right here? How many amps right here? How many amps right here? 4? How many amps went this way? 2.4? How many amps must have gone this way? 1.6. Has to have been 1.6. Which means that's 1.6 amps and that's 1.6 amps. Because there's nowhere else for that current to go. Ding, 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 ding. Do I know 2 things here? Then I know 3 things. What's the resistance here? Find the equation that has an R and a V and an I in it.
R equals V times I.
I don't think R equals V times I.
V over I.
Okay, you got to get the equations right. Can you crunch that on your calculator then? Can you go V divided by I? This one I don't think will work out evenly.
Wait, it's still, it's just a V. That means just one.
What's the voltage here?
One.
What's the voltage here?
Oh, 10. Okay, sorry, I didn't realize.
That's where we're getting these numbers from. So it's going to be 10 divided by 1.6. 6.25? So this has a resistance of 6.25 ohms. Do I know two things in this resistor? Then my final step is I go skiing. Now, I already went skiing on this circle. What other circle is there that I can ski? The big one. So let's do that. Let's go. Whoop! Didn't want to do that, Mr. Dueck. Let's go on that circle. So ready, Lyndon? How high? 32 volts. What do we lose going through this hill? Leaving? Keep going. Yep, 24. Keep going, keep going, keep going, keep going. How high? Don't know. How high? Did I get to the ground? Well, if that's 10 and you told me I still had 24 to deal with, how high does this hill have to be? What? Say it loud and proud. 14. Has to be 14 volts. Has to be. Ding, 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 ding. Do I know two things? Well, then I know three things. What's the resistance there? It's going to be 14 divided by 1.6. Again, this won't work out evenly. 8.75. Now, for giggles, how about we find the power? How many watts each of these is? How many watts is that one? Now, I can't tell if I've totally lost you, if you guys are just tired after spring break. How do you find power? Ah! Nothing? There you go. Welcome back, my angels. I've missed you all. Sorry? So, what's the voltage in this first resistor? 4. What's the current? Sorry, 8. What's the current? 4. How many watts? Got to be 32 watts. How about this middle resistor? How many watts does it have? It's going to be V times I, whatever the heck that is. 24 times 2.4? Not divided by, times. 57.6? How about the bottom right one? How about the bottom right one? How many watts?
22.4.
Is that right?
Yep.
Anyone else? I want a confirmation here.
22.4.
Hudson, you know how we're finding this, right? We're going V times I. So, Hudson, on your calculator, can you go 14 times 1.6? 22.4? And the top one, how many watts is that bulb?
15.
It's going to be V times I, 16?
No, 16.
So, what's the brightest bulb?
My mom says I'm not the brightest bulb.
No, that's not what they mean. What's the brightest bulb?
B, 57.6
Yep.
watts.
Okay. Couple more. Next page. This is why I wrote light bulb questions are a good test of student understanding of circuit laws. The brightness of a bulb is related to the power. Power is measured in what?
Watts.
Watts. Lena, you going to make it? Sure now. Therefore, it depends on the current and the voltage. I times V, or V times I. So you ready?
Yeah.
Says this, the light bulbs below are identical with a resistance of 8 ohms each. Which bulb is brighter? Ready? First thing I'm going to do is I'm actually going to label 8 ohms and 8 ohms. How can I tell which bulb is brighter? It's going to be whichever one has bigger power. Right?
Right.
So let's see which one that is. What's the first thing that I look for? What's the first thing that I look for? Battery, 10 volts.
10 volts.
Check. Then I look for, did they tell me total current anywhere? Do you see amps anywhere in this circuit? So that's not going to help.
No.
Then I said, I look for anywhere where they tell me two things. There's nowhere where they tell me two things. So then I go skiing. Ready? How many volts high is this chairlift? 10? If I go down this hill and I get to the bottom, how many volts must there be in this bulb? How many volts must we lose? Aiden.
10.
Okay. If I ski through here, how many volts must I lose going through this bulb? Also 10. Do I know two things? Then I know three things. What's the current going through this bulb? And what's the current going through this bulb? Calculate this on your own. Every one of you, try this. You have the voltage, you have the resistance, find the current. I'll give you a hint. I think it's going to be the same answer for both. You get, I'm doing this in my head, you get 1.2 amps? No, it should be even. 10 divided by 8 is 1.2 even, is it not? 2.5? Oh, 1.25? Good gosh, Dueck. You're on spring break still. Okay. How many watts? How many watts? How can I find power? How can I find power? V times I, you get 12.5 watts. 12.5 watts. So here's the question. Which bulb is brighter? It's a trick question. They're both going to be the same. They're both 12.5 watts. Now, if you suddenly unplugged this bulb, this one would be way brighter because how many amps are going through this circuit grand total? Well, grand total, I think it's 2.5 leaving right here because it's splitting up going this way and that way. This one would have more current and it would be brighter. Nearly done. Here, instead of having them separate, I have them in a row. I said each bulb is identical with a resistance of 8 ohms each. Which bulb is brighter? First of all, I'm going to put 8 ohms there, and I'm going to put 8 ohms there. Downhill is this way. This one is a bit advanced because we need to make some assumptions. And the assumption is this. Each of these bulbs has the same current. How do I know each of these bulbs has the same current? Even if they weren't both 8 ohms, they'd still have the same current. Are there any other junctions for skiers to go through? So all the skiers, all the current that leaves this chairlift has to go through that one and has to go through that one. So you ready? We're going to do some reasoning. Put your pencils down, look up, sit up. Both of these have the same current. Listen close. Listen, this is important. I'm going to do some reasoning. Both of these have the same current. Both of them have the same resistance. And they both have the same current, and they both have the same resistance, what can you tell me about their voltages?
They're the same.
Mateo,
They're the same.
they're the same. They have to be the same. You know what? This one is 5 volts, and this one is 5 volts. That's how you can get starting 10 volts high and ending at the bottom. You have to lose 10 volts, and if they're each the same, each hill, each resistor, each bulb is 5 volts. Do I know 2? Well, then find the current. Find the current. What's the current here? How can I find the current? I have the voltage, I have the resistance. How can I find the current? Hint, look at your yellow sheet. Sorry? Except that gives me V. I want the current. I want the one with the I by itself, right?
I equals V.
So can you do that on your calculators, please? I think you're going to go, are you not 5 divided by 8? Which is a decimal, 0.625? And it's going to be the same for the bottom one because it's also going to be 5 divided by 8, 0.625 amps. It's not what this question wants. This question wants to know which one is brighter. You know what, Amelia? In this one as well, they're going to be the same. Because if I go V times I, I'm going to go, come here, 5 times 0.625, 5 times, Mr. Dueck, times 0.625, and I'll get, for both of them, it's a pretty small light bulb. This is probably a Christmas tree bulb, or even smaller. 3.125. Could be like the bulb that's in your watch or something. Very, very low voltage. Very, very low power. 3.125 watts. 3.125 watts. We need to practice this, and I'm not sure whether I've totally nailed this or lost you, because some of you are still drooling. So I'm going to give you a bunch to practice today. Thursday, I'm going to do some together with you, but I'm going to let you struggle with it for the rest of class. Okay? So let me hit pause on the video, first of all, for a second. Okay? So I've given you a bunch of these to practice. It says, find the unknown voltages and currents. I've put the answers in brackets. Now, for some of these, you're going to be finding a bunch of stuff. You should find your answer there somewhere. I kind of put it in order. They are going to get a little tougher as we go along. I'm going to let you wrestle with these. And then next class, I'm going to do some practice ones with you and then give you the remainder of class to still wrestle with these. Tuesday, I'll take questions about this. Or do I see you guys this Friday? Probably not, since there was no school Monday. It would make sense. But who knows if this timetable makes sense. So you want your yellow sheet, your calculator, and this, and you may want those 5 steps that I gave you. Find the battery, find the total current, anywhere that has 2, 4 things, ski circles, and there was something else I said that I can't remember now. Okay. Let me pause the